All right, today we're going to talk about periodic trends. And periodic trends is a way for us to look at the periodic table and figure out how different elements are in relation to one another. When the periodic table was set up, we know that it was set up in order of increasing atomic number, which is the increasing number of protons. And because the number of protons increase as we go through the periodic table, this creates some trends. The other thing that helps us figure out trends is as we go down a group, the number of energy levels increases. So as we go through the periodic table, number of protons increase, and as we go down the periodic table, the number of energy levels increase. And these might seem like small things, but they create a lot of differences between our elements and create specific trends. So we are going to start with atomic radius. Atomic radius is just the size of an atom. So is it a large atom? Is it a small atom? So if we go to our periodic table, we can start to figure out what the trend is. So the general trends that we are going to look at is as we go from left to right across the periodic table, the atomic radius, I'm just going to abbreviate it with AR, is going to decrease. So that means that this side is large and this side is small. Okay, so let's think about why. Let's look at the third energy level, so we're going to look at sodium. Sodium has 11 protons in the nucleus. Magnesium has 12. Aluminum has 3. Silicon 14. Phosphorus 15. Sulfur 16. Chlorine 17. And argon 18. So we think of our nucleus and our outside electrons as kind of magnets. Right now, we only have 3 energy levels. That has not changed, but the effective nuclear charge is increasing. All the effective nuclear charge means is that the number of protons in the center of the nucleus is increasing. So you're having a stronger positive magnet in the middle to pull those electrons towards the center. So sodium is large and argon is small. Okay, so as we go left to right, it decreases. Now, when we think about going down the periodic table, atomic radius is going to increase. Okay, so here is our first energy level, and here is our 7th energy level. If we think back to the Bohr model, 1 energy level means we have a nucleus and 1 energy ring. Francium, we have 1 energy level and 7 rings. I don't think that's actually 7, but you get my point. Okay? As we go down, we're adding energy rings onto the atom, and so it is growing in size. Okay, so back to here, atomic radius. General trend is as we go across, AR decreases, and as we go down, AR increases. So you're going to see a question like this. Rank in increasing order. So increasing order is from small to big. Okay, so what I like to do, knowing this, I'm going to erase this. Whenever I'm asked to compare different atoms, I like to find my highest for that trend. So we said that atomic radius increased going down and decreased going across, right? So if it decreases going across, that means on the left-hand side of the periodic table, we are larger. And if it increases going down, that means that the bottom left is largest. So for atomic radius, francium is going to be our largest element. So now we have to look at what the question was. We had rubidium, chromium, carbon, and nickel. So what I would do is I would find all those elements. So rubidium is right here, and then chromium is right here, and then carbon is here, and nickel is here. So whichever one is closest to francium is going to be your largest, and then going in order to your smallest. So this question asked from small to big. So carbon, and then, what is that, nickel, then chromium, and then rubidium. All right, that's our first trend. Second trend, ionization energy. Ionization energy is the amount of energy it takes to remove an outer electron. We can have the first ionization energy, second ionization energy, and you can go on and go on. So the first ionization energy is just the first electron to come off. Second is the second electron to come off. Third, fourth, so on and so forth. But we're really going to focus on that first ionization energy. So let's go back to our periodic table. So the general trend that we are going to focus on is as you go across the periodic table, ionization energy, which I'm going to abbreviate with IE, is going to increase, okay? And as we go down the periodic table, ionization energy is going to decrease. Okay. So again, we said that the number of protons going across the periodic table is increasing. So if the number of protons are going across the periodic table is increasing, that means that we have a stronger magnet in the middle. Well, we know that positive and negative things attract. So if you have a really strong magnet over here and a weak magnet over here, the electrons are going to hold on tighter to that strong magnet than onto the weak magnet. So it's going to be harder to separate these electrons than it is these electrons. So it's going to take more energy to remove them. Hence, the ionization energy increasing. Okay, we're going to follow the same thought path. So here, we only have a few rings, right? And so our electrons are on the outside rings. Here, our electrons are all the way out here. Okay? These electrons are really far from the nucleus, so it's very easy to take them away. These ones are closer to the nucleus, so they're held a little bit stronger. So this is why ionization increases going across and decreases going down. So let's go ahead and make sure we have that on our notes. Okay, this question says, which atom has the highest ionization energy? Okay, so we're going to do the same thing that we did before. We're going to look on our periodic table and figure out what element has the highest ionization energy. Okay, well, let's just make that a little bit neater for you. Okay, so going across, IE increases, and going down, IE decreases. So if we know it increases going across, we're looking on the right-hand side of the periodic table. And we know that it decreases going down, we're looking at the top. So helium is going to be your element with the highest ionization energy. So again, we want to find the elements that we're being asked for. We're being asked for calcium, fluorine, phosphorus, and copper. So go ahead and mark those off. Fluorine, phosphorus, copper, and calcium. All right, so we want to know which one had the highest. Well, it's the one closest to helium. So our correct answer here will be fluorine. All right. All right, electronegativity. This is the ability to gain an electron. So electronegativity is a value out of 4. So our element that has the highest electronegativity is going to have a value of 4, and then all the other elements are going to decrease from there. This is not like a measure of energy, it's just how easy or how difficult it is for this particular atom to put another electron onto it. So when we go across the periodic table, electronegativity is going to increase. And when we go down the periodic table, electronegativity is going to decrease. So the general trend is as we go across, the magnet gets stronger, right? Because we have more protons. So if you have more positive buildup, that atom will do a better job of accepting a negative electron. Here, we have some positive buildup, but it won't accept electrons as easily. As we go down the periodic table, we have that positive buildup, but it's inside so many rings, so it's not able to reach all the way outside of the atom to pull an electron in. Okay? There is one exception to this rule. We know that our noble gases have a filled valence shell. Because it has a filled valence shell, there is nowhere to put another electron on that energy level. So we say that noble gases have a 0 electronegativity. So for this case, fluorine is going to be our element with the highest electronegativity. As we go across, it increases. As we go down, it decreases. So this is something you have to remember, that electronegativity excludes the noble gases. So, question that we have here is, which atom has the lowest electronegativity? So we said that electronegativity increased as we went across, and we said that electronegativity decreased as we went down. So let's go ahead and find our elements that it's asking about. Okay, so remember, fluorine is going to be our one with the highest, and the question asks about aluminum, barium, chlorine, and silver. So here's aluminum, here is barium, here is chlorine, and here is silver. Okay, so the one that's closest to fluorine is going to be chlorine, so chlorine is going to be our answer. Okay. Last trend, ionic radius. So we've already seen atomic radius. Ionic radius is very similar, but it's the size of an ion, where atomic radius was the size of an atom. Okay. So for the most part, ionic radius follows the same trend as atomic radius. So ionic radius, so IR, is going to decrease as we go across the periodic table, and IR is going to increase as we go across the periodic table. Again, because we have protons in the nucleus that are pulling electrons close to it, and as we go down, we have more energy levels. Okay? But the difference here is at our metalloid staircase, we switch over from being metals to nonmetals. And when metals and nonmetals form ions, they form different types of ions. So we have looked at the left-hand side of the periodic table forms positive charges, and the right-hand side of the periodic table forms negative charges. So positive means